Okay, so we're going to talk about debugging. As usual, if you have any questions or you want me to go back over something, just let me know. I'm happy to, pause at any point. So we're talking about JavaScript debugging today, and we'll just touch briefly on the term bug or computer bug, which was first coined by the programmer Grace Hopper. Um, and for more information on Grace Hopper, there's a Wikipedia here. She developed some of the very earliest programming languages, working with I guess the Army, or does it say on here? With the Navy. And so developing technology for the Army and the government and stuff like that. And I think there's a picture of the bug somewhere in here. Here we go. And so that's actually a picture of a bug that got stuck in a relay. Relay is like a piece of electronics that used to be part of like the very, very large computers that they had back at this time. And so the first computer bug actually refers to like a literal bug, a moth that was stuck in this like little piece of electronics that was causing the program that they were trying to run to fail. Um, and this, what you see here is like a log. So early computer programmers used to take these very detailed logs about what was happening in the computer program. Now the computer does that for us. We have logs that will, get printed out and give us information about how the program is running, but the programmers used to have to do this by hand. And so this bug was actually kind of taped into this log. Um, and so that's where the sort of term comes from. And generally today, we use it to refer to any type of flaw or problem with a computer program that causes the execution of that computer program to fail. Um, and so that can be a lot of things. In JavaScript, we don't have as many fatal errors as we do in other languages. And if you've never written another language before, that probably doesn't really make a lot of sense. But basically, what that means is that in JavaScript, because it was written to kind of make it easier for non-programmers to start developing, to make websites and create multimedia projects for the web, it doesn't. It has some rules where it's not quite as error prone as certain other languages. And in theory, that's supposed to make it easier to write the language because you're not just like getting bugs all the time. But in other senses, it makes it more difficult because if your program isn't doing what you want it to, but you don't get an error, you may not, you don't necessarily know why the computer program isn't working the way you want it to. So an error or a bug is really when we get something that's like a failure. So if I say something like, what's statement I could write that would not work? Let's say I said like variable x equals y. I'm going to get an error. So this program fails to run. And if I have an error like that in my P5 program, it will also fail to run. I won't see anything on the screen. Um, Other types of errors, like for example, if I say something like variable x equals 1 times 5, this actually did not make my program fail. It ran the program. I didn't get any type of error, but when I type in x, oh, I do get 1 times 5. Let's try a different string. Let's try 10 times 5. Okay, so now I have a different type of problem, which is that x is not actually a number. And that, if I did that in P5, I would still probably get my program to run, but it wouldn't do what I wanted it to do. So let's take a quick look. I'll open up P5 and just do examples of both of those possible problems. So if I have a simple program and I say variable x equals y, and then I have a circle or an ellipse at x and y and 50, if I try to run this code, nothing happens over here. So if you didn't have the console open, it would just look like nothing happened at all. Or we might see like a red highlight like this that tells us there's an error. So that lets us know like, this isn't working correctly. But if I have an error that isn't a fatal error, so let's say I tried to say x equals 10 times 5, and then I run this program. So notice now there's no error, but I don't have an ellipse, right? Because x is doesn't equal anything. It's just not a number, it's a nan. So if I log x, I'll see that x is nan. And so with JavaScript, sometimes I have to figure out why something's not working, even though it seems like it should be working based on the code and the lack of errors. So if I fix this to say 10 times 5, now we get our circle. So in JavaScript, we have both fatal errors, but we also have bugs that are not actually throwing errors. And so to find those bugs, we use the console. So I already have the console open, but as you guys know, if I want to open the console on a Mac, I can hit Command Option and J all at the same time. On Windows, I can hit Control Shift and J all at the same time. This is specifically for Chrome. For other browsers, I think there are other key commands, but I'm not sure what they are off the top of my head. But you can Google them, or most browsers, if you right click and there'll be some option to go to inspect, and that'll usually take you to the Elements tab, and you can go over to the console to get there. So I've used the console a little bit in class just to do examples using JavaScript, but now we're going to use it for what it's really intended for, which is debugging and testing our program. So the console is actually a really, really nice tool that's built into all of the browsers that makes it really easy to test parts of our program if we're writing JavaScript. And this is nice because it's built into where our program exists. So usually when we're writing code on another platform, we have like a text editor, then we have to build the program, and then we may have like a whole other console that we're logging messages and errors in. And the nice thing about JavaScript is it's all kind of built into the environment that we're using, which is the browser. So it's easy to create errors. If I say x plus 1, although x I did define, so let's use z plus 1. So there's an error, and it tells me z is not defined. And so a lot of the errors will not tell us exactly what we need to do to fix them. P5 actually does add some stuff that may give you more hints than the basic JavaScript errors. But the basic JavaScript errors usually just tell you what the error is and where you can find it. So they'll tell you what line it's on. So right now I'm in the console, so it's not on a line for our script. But if I have P5, let's make this an error again. Usually it'll tell me exactly where this error is. So it'll say y is not defined at sketch line 4. And the console that's built into the P5 editor is pretty similar to the console we get in the actual browser. It's going to put some of the same information, but it doesn't have all of the same information. So we're only going to get stuff that's related to our code. So this console that's built in down here is similar to, but not exactly the same as the browser console. But anyway, it says y is not defined, and it actually tells us where to look. Sketch, and then this first line, this first number after sketch.js is line 4. So we can look at our code, line 4, and it even tells us how many characters into the line it is. So it's like, it says 13, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I guess it's not exact. Maybe the 13 doesn't mean characters, but anyway, I'm not exactly sure. I think it means characters. Maybe I just can't count. But P5 actually adds even more information because P5 is, partly created uh, for educational, purposes. It actually adds more information about certain common errors. So it says y is not defined in your current scope. If you have defined it in your code, you should check its scope, spelling, and letter casing. So it still doesn't tell us exactly what we need to do, but it does give us a little bit more information about what we might be doing wrong. And it even has a link to kind of explain how variable scope works. We actually haven't learned this yet because we haven't learned functions yet. We'll probably learn it in a couple weeks. So sometimes as we learn, things won't make as much sense, but we can try to interpret them as best as we can. So how do we debug? Part of in this section, part of what I'm talking about is just like practical advice, and part of it is also like kind of psychological, because programming can be really frustrating, and debugging or getting good at debugging is one way to kind of ease that frustration. So as you write more code in this class and in other classes, you're going to run into bugs, and it's a lot of the time you're not going to know why your code's not working. It's going to be very confusing. And so part of debugging is not just the like logistical like process of looking for bugs. It's also a psychological thing of being able to like realize what's happening on the computer and not get frustrated. So if something's not working the way you want it to, instead of, and pretty much everyone does this, so if you've experienced this already, it's not a big deal, but you don't want to get upset and try a million things and rerun your code a million times and, click the play button 100 times. What you want to do is start asking yourself questions. And those questions are, what did you expect to happen and what's happening instead? So that's kind of how we can frame this. So if your code's not running, if we have a sketch like this and we're trying to draw an ellipse and we don't see anything there, we might say, the computer hates me and it's not doing what it's supposed to do. But the computer doesn't have, human feelings or emotions or thoughts. It just does whatever you tell it to do. So we need to take a step back, and sometimes just like literally taking a break for 5 minutes, or even just not working on something for a day and coming back. This has happened to me like literally dozens of times where I'm up late coding something and it's not working and I finally give up, and then the next morning I look at it and realize I had a really obvious misspelling or the wrong operator or something like that. So part of it is just a mindset of removing yourself a little bit from what you're writing. So the first step, or the zero step in this case, is to ask yourself, what did I expect to happen and what happened instead? So this is what I hear a lot of students say when they first learn to program is nothing's happening. And so the next step of that is, what did we expect to happen and what is happening that instead? So if the program's not running, why isn't it running? Or if we don't see an ellipse, why don't we see an ellipse? And that can give us a framing for looking at our code and looking for where we might have gone in, had an error. So next thing is just checking the console for error messages. So if we're lucky and we had a bug like this where there was an actual error, then usually even if we don't know exactly what we're supposed to do based on this error, we at least know what line it's on. So that is really a pretty good advantage of at least knowing exactly where we want to go to figure out where did my code go wrong. So a console, having the console open is really, really important because you'll see errors before, you even running your code. Like as soon as I run this code, the error pops up. So you always want to have your console open so you'll see if you get these errors. And once you get the error, you can look, and if if it's obvious, you can just fix it. If it's not obvious, then you might have to think about what is happening in the code, and that might take longer. But at least with an error message, we can figure out if there's an actual bug in the code. If there's no error message in the console, that means we have a conceptual gap between what we expect the program to do and how it actually works. So that would be back to my 10 times 5 example. So in this case, I'm going to take out this log for a second. Whoops. So in this case, there's no error, but I still don't see my circle. So this is what we call a conceptual gap, that I'm expecting this code to do one thing, but it's not doing that. So now I have to go back and look at this code and say, what did I miss? What's happening here that I want to happen, and why isn't it happening? And the obvious answer is I'm trying to get 50 by multiplying the string 10 and the number 5, but the string 10 is not a number, it's just the letters TEN. And so P5 can't actually do that math for me. And that's my conceptual gap. So once we know that, if we have an error, we can just read it and deal with it. if we don't have an error, now we have to test our program. And that's where this console.log thing that I've been doing comes in. So the console is this thing on the right, and we have access to it just using the word console. So it's kind of similar to like our document or our window. It's just a big JavaScript thing that has a lot of stuff in it. And there's a lot of different stuff we can do here, but the main one we want to do is log. And log just refers to adding something to the log, like we saw with Grace Hopper's log earlier. So when I say, whoops, when I say console.log, I can write anything inside of these parentheses and it will add it to my console's log. So if I say hello, it adds it to the log here. And I can actually add like multiple things, like I can say hello, X, Y, Z, and that gives me an error because these values are not defined. So let's just do some numbers for now. So I could say hello, 1, 2, 3. And it's going to log all of that stuff in there. I can also log things like objects. So I can say console.log the document. And so there's our document here. I could probably console.log the console. If I console.log console, there we go. There's my console again. So console.log is just an easy way to test different parts of our program. So in this example, the way that I can figure this out is say, well, what is X if this circle is not showing up? Because I know ellipse is right, I know 50 is a number, I know this 50 is a number. So this X doesn't seem to be working. So what is X? And when I do console.log, now we see in the console that it's not a number. And so now that I know this is not a number, I can say, oh, this is silly. I need to use a number here. And now we have an ellipse. If I had a different type of error, like x times y, this already tells me that y is not defined. But if I try to console.log y, it'll do the same thing, although it doesn't get to the second error because we still have an error up here. So that's how we can log different variables. And we can also log other parts of our program. Like if I wanted to console.log ellipse, we can see if that, there's something wrong with that. And it shows me it's a function, so that's probably what I expected. It doesn't really tell me a whole lot else, but at least I know that it exists. If I had it spelled ellipse wrong and I tried to log it, it would tell me, ellipse is not defined. So we can really console.log practically anything in our code, and we'll see what it is in our program. Okay, so if you've gotten that far and you still haven't figured anything out, that's when we go to doing some research. And what I recommend here is just going straight to Stack Overflow for JavaScript related things. You can just Google stuff. So if you have a question, like let's say X is not defined, if I just Google this, most likely you will see some stuff that's related to what you want to do. And also most likely, like the first, like literally the first Google result after this hoisted result here is from Stack Overflow, which is the website that we were just on. So, and it's also about JavaScript. So literally this is a very common error. And on Stack Overflow, usually they'll have some kind of explanation. With Stack Overflow, it's a user compiled site, so people can ask questions, other people write answers, and then people can vote on those answers. So if I say X is undefined here, I might get some different results. It wants to know if I'm a person. And so now I get some questions. What are the scope of variables in JavaScript? So I don't see my exact question here, my exact error here. But here we go. And then you can also look for different tags and things like that. So um, let's go to advanced. So we can put a tag inside of brackets. So if I want it to be tagged with JavaScript, I can do that. X is undefined with JavaScript. And now all of these results should be related to JavaScript. I could also put P5 in here, see if there's any P5 results. Okay, we didn't get any P5 results. Let's see if there's any just P5 results. Okay, so there's nothing for this with just P5, but if we say undefined with P5, I guess there's not a lot of stuff tagged with P5. Let's see just P5. Huh, there's no questions tagged with P5. That's interesting. Okay, that's fine. We can still use JavaScript. So Stack Overflow is what you want to use, but Google is also a good option. So just do some research, look up the error that you're seeing, or just try to ask a question. Sometimes being able to ask the question correctly is an important skill when it comes to debugging. After you do your own research, ask a friend. So you could post a question on Discord, you could send me a question, you could ask somebody else in the class. Sometimes something that's really simple that we're not seeing when we're writing our own code, somebody else will see it and immediately know how to deal with it. And then finally, once you've spent a lot of time and you haven't gotten anywhere, just take a break for 5 minutes or an hour or a day, and you'll come back and you'll probably see what the issue was. So a few more guidelines. Don't delete your code. If you're having an error, like let's say I still am having this issue and I don't know what's going on, instead of just like deleting this, I can always just duplicate. So if I save this as, this is broken or whatever, I can always just duplicate this. And then start over so that I don't lose the other code. Because even if it never works, it could be something that you could learn from in the future. So don't delete your code. You can even, you can always also just like comment out the part that doesn't work and just, keep going. There's no reason to delete your code. We can very easily make lots of copies of this. Yeah, just leave whatever it is that's not working, and we can probably figure out what's wrong with it later. This doesn't really apply since we're using the online editor, but when you're editing files on your computer, a lot of time you might be editing the wrong file and not realizing it. So that's also something that you always want to check for. As I said before, you should always have the JavaScript console open pretty much all the time if you're working on a web-based project, whether it's P5 or any other project. If you're doing something online, you should have the console open all the time. Console.log, we have gone over. Here's a few common errors, and I'll see if I can make examples of all of them. So syntax error is when you have syntactically invalid code. So an example of that would be if I said something like variable x equals 5, and then I just put like another variable here, or actually that's going to give me an undefined error. What if I said like variable x, but then I forgot to put equals and I just put a 5? That's going to give me a syntax error. And so usually this says uncaught syntax error, unexpected number. And so it doesn't say like you're missing an equal sign because it doesn't really know what you meant to put here. But it is telling you a little bit that basically you can't just say variable x and then 5. There needs to be some type of operator here for it to know what's going on. It should be like equals 5 or plus equals 5 or equals, something else. So that's what unexpected number means, and that's usually when you'll get a syntax error. Reference error is for a non-existent variable, so that's when I say x plus z. I get a reference error, z does not exist, so it can't do this math because z has no value because I haven't defined it. Fail to load resource. You'll see that a lot later if you don't have the right path for an image or something like that. Um, I could try to do that in P5. I don't think I can do that in the browser. So we'll learn this later, but eventually we'll load images using a preload function. And I might say something like var image gets load image and then my image.png or whatever. And if I run this code, I'm going to get an error. And I think if I look at it in the console, we'll see. Yeah, it says failed to load resource. So that happens when you try to load something into the browser that isn't in the place or doesn't exist. And then nan is not a number. We've already seen a bunch of examples of that. It's not technically an error, but it's a null state that we want to avoid for the most part. Okay, so let's do our debugging challenge. So I'm gonna give you guys a link to some code, and it's got like, I don't know, 10 or 20 bugs in it. And when you're done debugging, it's going to look like this. So the link, where's the link? I should have the link right here, but it's back on week 3. So it's right here. And what I want you to do is open this link up in P5 and then just immediately duplicate it. So just go to duplicate, and that'll create a copy of the project in your own account. And then if you run this code, you're going to notice nothing works and it starts with an error. And one of the things with JavaScript is as soon as it finds an error, it just stops running. So it doesn't tell us every error in here, but once you solve this error, you'll get another error and you can work on that. And eventually you'll get through all the errors and you'll see something that looks like this. And so when you see this, you know that you've debugged all the errors. So not all of the issues in here have an error. Some of them are, as we talked about, conceptual gaps where it doesn't look like what it's supposed to look like. So your goal is to get it as close to this image as you can. If it's a little off, don't worry about it, but you should be able to get it pretty close to this image. So I'll put a link to this in the voice channel chat. And for this one, you don't need to post on OpenLab. Just submit the link on Blackboard once you're done with it. That's enough for this one. We don't really need to document it. So it's just an in-class exercise. So as I mentioned, just duplicate the sketch and then solve the errors. And once you've solved all the errors, you can submit your finished version on Blackboard. If you get stuck, I recommend to put a question or something in the chat. And so maybe some of your classmates who have already gotten to that point could help you, or if not, I can always help you as well. So if you get stuck on anything, don't be shy to ask questions. We can all kind of help each other out with this project. Um, and yeah, that's this in-class assignment. I'm going to stop.